Hello everybody, now we are going to start our next chapter, that is divide and conquer. So in this chapter we are going to do some questions, and those questions we are going to do using a technique called as divide and conquer algorithms. So whatever the questions we are going to do, we do with a strategy. That strategy name is divide and conquer strategy. So in life, whenever we get a huge problem, or in coding, whenever we get a huge problem, generally we break that huge problem direct. We can't directly bang on it and can't like find the solution for that particular huge problem. So what we do in this scenario, right, we break that particular huge problem into small teeny tiny pieces, and we try to find out the solution for that particular small piece. So solution for small piece. So we try to find out the solution for each small piece, and finally by combining all those things, all those small pieces, we get a answer for our huge problem. Solution for our huge problem, we'll get the answer for it. So this is the strategy we are going to do in this whole chapter. So first of all, what we do, we divide our first problem is first strategy. First thing is we need to break or divide our small huge problem into small teeny tiny pieces, and we try to find out the solution for this thing. And after that, third step will be conquer step. This is the second step. We try to find out the solution of small teeny tiny pieces. After that, third step is nothing but combining those solution, or in other words you can say conquer. So we try to conquer on each small tiny piece, and we will combine all those things such that we will get the solution for our huge problem. So in 1920s and 1910s, Britishers used the same technique. They use a strategy called as divide and rule strategy. So they used to divide like small kingdoms. They used to like first of all divide people, and like spread sense of fear in them, a sense of fear in people. After rule on small groups, such that by ruling on small groups, they like conquered all over India, and they become the superpower. A super like ruling kingdom all over the India for like 100 or 200 years. So this technique they used. So the technique they used, Britishers used to rule India, is divide and conquer. So we are not gonna like talk about the history or anything. I just want to tell you that using those technique, we are going to solve our coding problems, not like real world problems. We don't like put fear among people, but we are going to do coding level questions using this same level technique. Now let us talk about what we are going to learn in this chapter. So using divide and conquer technique, we will learn about some sorting techniques. I told you now that other than like bubble sort, selection sort, insertion sort, counting sort, there are other techniques also for sorting a particular algorithm, and those techniques are based on that particular topics. So some techniques is based on recursions, some sorting techniques is based on backtracking, and some other sorting techniques are based on some other techniques. So divide and conquer is a part of recursions. So we'll use the same approach as we used in previous chapter like recursions. So we will use the same approach, but here we will divide our problem into small teeny tiny pieces. After it, we will try to find out the solution for each piece. After, finally we'll combine all those solutions to get our huge problem solution. So these are the strategy we are going to like learn. And in this chapter we are going to do some questions like some sorting techniques like merge sort, quick sort, which is like efficient than our old sorting techniques we learned. Like in basic sorting algorithms, we learned like around 4 sorting techniques. So we are going to learn some efficient sorting techniques. After it, we are going to learn advanced level binary search question. So these are the things we are going to learn in this chapter, in this particular chapter. Now first of all, let us talk about merge sort. So in basic sorting techniques, we what we learned, first of all we learned about bubble sort, selection sort. After it, insertion sort, counting sort, and we learned about a new like computer based or Java compiler based sorting technique, that is inbuilt sort. So these are the like 1 2 3 4 5 sorting techniques we learnt in bubble sort, or sorry, basic sorting algorithms. Now we are going to learn about merge sort. So the time complexity of merge sort is, remember guys, that log n time. So these all sorting techniques like used to give us like big of n square, right? Except this will give me log n time. So these three sorting techniques, these three basic sorting techniques used to give time complexity around big of n square in worst case scenario. Similarly, our merge sort will give us time complexity in n log n time, right? Okay. So this is our unsorted array, and we already know that what is the meaning of sorting. So either arranging our elements in ascending order, or either arranging our elements in descending order. This is known as sorting, right? Okay. So here this is the unsorted array, and these are my indexes 0 1 2 3 4 5. So we'll sort these particular given index using merge sort in ascending order. So the ascending order or increasing in the increasing fashion, these are the elements. This is how the elements looks like. First of all, 2 will come, after 3, after 5 6 8 9. So this is how we are going to sort our given array in increasing order using merge sort. So let us talk about the approach, how we can solve like particular given merge sort question, or what are the things that we need to know to apply merge sort in the given question. So before we dive into the technical aspects of this question, I want to tell you that merge sort is a very important concept, very important concepts. In some interviews, merge sort questions might like directly come, and interviewer like directly ask you like apply merge sort on this particular given array. So merge sort is important. You will get in your exams also about merge sort, and you can see these merge sort question in like coding platforms also. So it is considered as very important question. So you need to understand the basic approach, or the approach of how we can do merge sort, and what are the things that we are going to do in merge sort. After it, how the code works of merge sort, right? And remember guys that merge sort is like a way efficient code when compared to basic sorting algorithms, right? Okay, now let us talk about what is the approach for doing a particular question of merge sort. So the approach is, first approach is divide, right? I told you know that first of all we'll take a huge problem and we'll break into small teeny tiny pieces, and we'll try to find out the small question, small like piece solution. After that, by combining all those things, we'll get our required or desired solution of our huge problem. So this is the technique, this is the same technique we are going to follow in merge sort also. So what we do here is, first of all, to sort a particular given array using merge sort, what we do, first of all, we divide elements. We like will this is the given array, we'll divide those elements into, we'll get our base case. If we got our base case, then we'll start to combine all those elements from the base case. So this is how the basic structure or the functioning of my merge sort. Now what we need to do here, first of all, first step will be dividing step. So to divide, we need to know our mid, and we already studied in like basic sorting algorithms that our mid is equals to starting index plus ending index divided by 2. So this is how I can able to calculate my mid value, right? So these are my indexes 0 1 2 3 4 5. Now let us take that this is my mid, this is my mid. So what I do is I will like uh, separate these elements, separate the element into left part and the right part. So I will start like to divide our given array towards the left part and the right part like this. So I will take mid. After taking mid, after calculating mid, what I will do is I will divide the left part and the right part separately, right? So what I will do, I will just, this is my left part, right? So I will take separate from the given array. I will make it like separate from the given array. So this is 639. After that, this is my right part, right? So 5 2 8. So I will like continuously divide the given array until I get a single element. Okay, this process will get continue until I get single element. So again, this is let us consider that this is my mid, right? Here this is my mid, and here this is my mid, right? So I will again like divide this given array, that 6 3, after that 9. Similarly here, this is my mid, this is my mid, this is my 8 value. So what I will do, I will do like a left. After it here 5 2, this is my given array. After it, this is 8. Again I will, what I will do, this is my mid here. So I will again divide or split our given elements, that is 6, after it 3. And similarly here, what I will do, I will do the same thing, that is 5 and 2. So when I get the single element, can I say that the single element is itself sorted? So the 6 is sorted. after that 3 is also sorted. So when I get those single element, there is no need to compare. Like suppose let us take that 2 3 4 5, this is my array. So can I say that this element is sorted? Yeah, sorted. Let us take another example, 501. Is this sorted? No, it is not sorted because the elements are arranged randomly. So can I tell that I can say that particular given element is particular given array is sorted based on comparison of two elements? So if the elements are not in order, so can I say from that particular scenario that the given element or the given array is unsorted? Yeah. Now let us take an example. Let us take an example that there is only one element in my array. Let us consider that this is my array and the element which is present in the given array is 1. So can I like tell that given array is sorted? Yeah, because there is only one element. That's why the given array is sorted, right? So from this example, what I can say that that if in any given array, if there is only one element present, then the given array is sorted itself. Okay, so here what I did, I in my example, in my merge sort example, the array which I have taken, what I did, I started to divide two as my left part and my right part, and I will continuously doing the dividing part until I get my base case. And the base case is if the element or the in the array, given array, the element become a single element such that it will become sorted itself. So can I say that 6 is sorted, 3 is sorted, after that 9 is sorted, right? After that 5 is sorted, 2 is sorted, and 8 is also sorted. So this is my first part. So this is my first part of after that the second part will be, I will call my merge sort for my left part. After that I will call my merge sort for my right part. So this will become my recursive step. So what I will do, what this particular step means, I will tell you, right? This is the given array, right? Let us consider 6 3 9 5 2 8. So what I will do here is, this is the given array, right? Okay, so this is my left part. So I will call merge sort for my left part. After that I will call merge sort for my right part, 5 2 8. Okay, right? Okay, I will call my merge sort for my right part. After that I will call merge sort for my left part. So what merge sort will do, what is the work for the merge sort? The work for the merge sort is to sort the given array. That is the simple work. So merge sort left, what it will do, it will sort the left elements of my array. After what merge sort right will do, it will like sort the given right part of my array. So this is the given array, right? So this will sorted into, because of merge sort left, we don't need to like think about what is the logic going on in the merge sort right now. You just have to believe that merge sort left will sort the given array of my left part, and merge sort right will sort the array of my right part. So we just have to like believe, because our recursive function will do it. So you can see that what I'm doing in the first step, I'm dividing. After the second step will be, I'm calling my merge sort for my left. After that merge sort for my right. So these calling will continue until I reach my base case. So what is my base case? Base case is the single element. You can see that 6 is the single element. So this is my base case. 3 is the single element. This is the base case. After that 9 is the base. 9 is the single element. So this is the base case. After that 5 2 8. So these are the sorted elements itself. These are the sorted elements. So what merge sort left will do, it will sort the left part. Elements. After what merge sort right will do, it will sort the right part of my given array. So here the elements will become 3 6 9. After here the elements will become 2 5 8. So this is my second step. After that what I will do, I will call my like merge sort. After that I will you can see that in the first part I have like divided all the elements. Now what I told you that the basic strategy, basic funda of divide and conquer algorithms is, will take a huge problem and will break into small tiny pieces, and will try to find out the solution of that particular small piece. After finding the solution of small pieces, we'll combine all those pieces such that we'll get the huge problem solution. So here the huge problem is, we need to sort the given array using an algorithm called as merge sort. Okay, this is our huge problem. Remember guys, what is our huge problem? Huge problem that we need to break our given array, or we need to sort a particular given array using merge sort. This is our huge problem. You need to fix it in your brain that what is the huge problem. Huge problem is we need to sort our array using a efficient code which is having a time complexity of big of n log n. Okay, so okay, so what the approach tells us, what the approach of divide and conquer will tell us, the divide and conquer approach will tell us that we need to first of all divide. We need to divide. What I told you, that we need to divide the given huge problem. So what is our huge problem? We need to sort the given array. So to sort, what I am doing, we are dividing the given array into two pieces using mid. By calculating the middle element, we are like dividing the array into left part and the right part. After calculating left part and the right part, these division will get like continuously called until I get a base case. The base case is single element. So if I get the base case, then I will stop dividing, because there is no, like, I can't divide a single element because there is only one element present in my given array. So these division, you can see that left part 639, after 63, after 6. See, these division will continue until I hit my base case. So this is my base case. So when I hit my base case, what I will do, I will call my merge sort left. After merge sort right. So merge sort left and right will sort my left part of the given array after right part of my given array. So after sorting, after finding the solution of small piece, what we need to do, we need to combine all the solutions. So for combination, I create the function that is merge. So what merge will do, merge will like combine all the solutions, all the single elements, and it will give us a final given array. So let me like draw here such that you will understand it even more better, right? So this is my given array, right? This is my given array, 6 3 9 5 2 8. This is my given array, right? So what I will do, I will like first of all break these solutions. After that, first of all I will break 6 3 9. After that 5 2 8, right part, left part. After that 6 3 9. After that 5 2 8. After that 6 3 9 5 2 8. So what I did, I break my huge array into single elements. After that merge sort right, merge sort left will like combine these elements into like according to their order, according to their like comparison. So merge sort right and merge sort left will like arrange our elements in such a order that I will finally get my like given elements in sorted fashion. So these are my elements, right? 3 6 9. After 2 5 8. So merge sort left will sort the given array on the left side. So it will sort the given array like this. So merge sort left will sort the left part of my array like this, 3 6 9. After that, merge sort right will sort the given array like 2 5 8. After that, the third step is, what is the third step? We need to merge the given elements. So we need to merge these two elements in such a way we will get our like sorted array, right? So this is my iterator for my left merge sort left. After this my iterator for my merge sort right. So I will compare these two elements. What is the shortest element in both 3 2? 2 is the shortest. So I will take this is my, I will create a new array, temporary array. I will like the size of my array is like this. So how many? 1 2 3 4 5. So 1 2 3 4 5. Okay. So I will like first of all put 2 in our temporary array. After our iterator will come here after 3 and 5. Which is the biggest element? 5 is the biggest. So 3 will get printed here. After my iterator will come here. After among 6 and 5, which is the largest? 5 is the largest. After iterator will get changed for my merge sort right. After 6 and 8, which is the smaller one? 6 is the smaller one. After iterator will come here. After among 8 and 9, 8 is the largest, 8 is the smaller one. So such that I will print 9. So finally, by merging all the elements, we will get our sorted array in our temporary array. So this is how we will create a new array. Remember guys that in merge sort, we create a new array to store our sorted elements. Right, after it will like copy all those elements in our given array. This is my ARR, right? So I will copy all the elements of my temporary into my ARR array. So these are the three steps which are involved in merge sort. So let us see how the diagram should look like. So here, this is the huge problem. This is the huge problem. So what I'm doing here, I'm doing here, first of all, I'm dividing. This is my first step, divide. After that, you can see that I have like divide those elements into small tiny pieces, such that here this is the separate element. Actually, yeah, this is the separate elements, both are separate, right? Okay, so you can see that I am like dividing those elements into single pieces. So this is my base case. So this is my base case. After that, I am calling my merge sort right. Here I will call my merge sort right, merge sort left. After that, merge sort right. So what merge sort left and merge sort right will do, it will sort the given array on the left part and the right part. So I am calling merge sort right. After that, what I am doing, this is my second step. So finding solution is my second step. After that, third step will be combining or conquering. So here I am conquering, I am combining all the solutions. You can see that I have like gotten the left part sorted, after that right part sorted. After that, I have shown you that using iterator will create a new array and will copy all the elements to my given array. So this is how the summary or the diagrammatic representation of merge sort looks like. So I hope you have understood the concept of merge sort. So what we'll do, we'll take our array, we'll break into two pieces, left part and right part, and the breaking will get continued until we hit our base case. What is our base case? Single element. So if in the given array, if there is only one element present, then that is my base case. You can see that in our base case the elements are 6, 3, 9, 5, 2, 8. So this is the base case. When I reach my base case, I will call my merge sort right. After merge sort left. So these two, merge sort right and merge sort left, will like sort the left part of my array, after right part of my array. After sorting the left part and the right part, I will combine both by comparison, and I will arrange my elements in such a way that I will get my final solution. So these are the three steps. I hope you have understood. Now let us code this thing. First of all, I need to import my public, import java dot util dot star. After that, I need to create my class, public class java basics. After that, public static void main string args. In this, first of all, I am creating my array int arr is equals to my example. What is the example I have taken? 6, 3, 9, 5, 2, 8. So this is the array I have taken as the example. Now I am creating a function. I am creating a function for my merge sort. Merge sort. So public static void here static public static void merge merge sort. In this I am passing my int arr. After it, my starting index, int starting index. After it, int ending index. After it, what is my base case? So if in my merge sort code, if my starting index is greater than or equals to ending index, if I reach this scenario, that is my single element, if there is only one element present in the given present in my array, then what I will do, I will simply return. That's all. After it, my work. So what is my work? I need to first of all calculate my mid is equals to starting index plus ending index divided by 2. After it, what I need to do, I will call my merge sort merge sort for right part of my array. So I will call merge sort for my right part first. So int arr. After that, here I will pass my starting index up to mid, right? I will pass mid here. After that, I will call my merge sort. Here I need to do merge sort for mid plus 1, that is my right part of the array up to ending index. So here this is my right part. After this is my left part. So I need to calculate the merge sort for my right part and the left part. After calculating the right part and the left part of my given array, after merging, after calling merge sort, I need to do my third step. That is, after like sorting all the right part and the left part, I need to combine both, right? So I need to call my merge function. So merge function. In this I am passing my int arr after starting index, mid, ending index, right? Or after that I am creating my function public static for merge. In this int arr comma int starting index comma int mid value, after that int ending index, right? In the merge sort function, first of all, what I told you, we create a new array to store all the elements which are sorted, which are like literally sorted using merge sort, right? So we are creating a new array, that is temp is equals to new int of size ending index minus starting index plus 1. So what is the size of my given temporary array? That is equals to my given arr, or in this I can write also arr dot length. So you can see that at every like calling, at every calling of merge sort, I need to like define this merge sort on top of our function. Yeah, now it won't show error type. Yeah, I need to give here return type also, that is void. Yeah, that's all, right? Okay, so here the length or the size of my temporary array is equals to the given array length arr dot length. So you can see that at every call, when I am merging, the size starting index and ending index will change because of recursive call. That's why I'm not giving that like arr dot length, because the length of arr is constant, right? The array size is not changing, but the starting and the ending index is changing, because we are dividing the elements, right? Such that if the starting and ending index will change, because of that I am giving my size of the array is equals to the ending index minus starting index plus 1. I hope you have understood the concept. After that I need to store my starting index, int I is equals to starting index, right? So these will keep an eye for iterator for my left part, for left. After that int j is equals to ending index. So this will keep iterator for my right part. After that I am creating int k is equals to 0. This is the iterator. This is the iterator for temp array. Right? So I have created I, j, k to keep track on my like left part of the array. After that I need to merge all the elements, right? I told you now, like we create two iterators and we'll compare at each index. We will compare if the present iterator, if the of my left part is greater than the second part. If yes, then put on the first side. So here this is how we are going to merge. In this function, what is the main motive? We need to merge the given array, right? So for this we have created int I is equals to right starting index. This will keep track on my left part iterator. After j is equals to ending index, this will keep track on my right part iterator. After k is equals to 0 is my iterator for my temporary array, right? For traversing I create this array. After that I am running a loop while my I should be less than or equals to mid and j should be less than or equals to ending index. If this any of this both conditions, if both of the conditions is true, then I will come into my loop. After that I need to check, right, if my left part array element is greater than my right part element. If yes, then put the right part element on the first, because we are sorting in ascending order. That's why we are doing this. So I need to check, I need this is the step of comparison. I need to compare at each step. Okay, so here arr of I, if arr of I is less than arr of j, then it means that the arr of I is less than arr of j. If this condition is true, then I need to store in my temporary array arr I value, right? So temp of k is equals to arr of I. After that, you can see that suppose let us consider 3 5, right? So I have stored the value of 3. So what I need to do, I need to move the iterator, right? I need to move the iterator. You can like watch the approach of the question. You can see that I have changed the iterator at each after each comparison, right? Here similarly I need to change my iterator for my left part. After that, if my given ARR of j is less than ARR of I, then what I need to do, I need to do like a temporary of k. Temporary of k is equals to ARR of j. After that, I need to increment j plus plus, and uh, in the both step also, whether j is greater or k is greater, what I need to do, I need to increment anyways k plus plus, because I need to store the elements on my next index of the given array, a given temporary array, right? Okay, this is how the code for merging works. And one more thing, that if any of the elements left, if if any elements, we have like compiled all the elements. Suppose if the any given scenario some elements are same, then at that scenario will get left out by some elements, so those elements will get missed out. So to avoid that, to avoid like any missing of the element, we need to run again while loop for my left part and my right part, and will need to store all the elements in my given temporary array. So to like avoid to, if any elements like left out for this scenario, we need to run a while loop. So first of all, for part of my array left part of my array, I'm running a loop such that I'm checking in this any one of the element are left out. If yes, then include in our array. Okay, so I should be less than or equals to mid. Here what I need to do, temporary of k plus plus is equals to ARR of I plus plus. Similarly, for my right part, while j should be less than or equals to ending, right? Okay, here temporary of k plus plus is equals to ARR of j plus plus, right? After that, I need to copy from my temporary array to my actual what are the elements present in my temporary array. I need to copy those elements in my actual array, right? For copying, I'm like running a loop for to copy all the elements from the temporary array to my actual array. So for that reason, I'm running a loop k is equals to 0, and I should be I is equals to starting index. After that, k should be less than temp dot length. After that, k plus plus comma I plus plus. Yeah, in this I need to copy ARR of I is equals to temp of k. That's all. Now in the main program, I'm calling my merge sort function. I'm passing ARR. After my length ending index, how many elements? 1 2 3 4 1 2 3 4 5 6. So ending index is 5. That's all. After calling my merge sort, I am printing my elements. That is int I is equals to 0, and I should be less than ARR dot length. After that, I plus plus. In this, I am printing system.out.print ARR of I. That's all. Now let me remove ln here. After that, add a blank space. Now you can see that first of all what I am doing. So in the main function, I have created array int ARR is equal to 639528. After that, I called my merge sort function. In the merge sort function, I passed my ARR array. After that, my starting index. After that, my ending index. Right? I have passed starting index, ending index. After passing, what I'm doing in the merge sort function, this is my base case, that if my starting index is equals to my ending index, that means only one element is present. If only one element is present, then what we need to do, we need to write return out of the program, right? So what work I'm doing here, here first of all I am calculating the mid value. Mid value is equals to starting plus ending divided by 2. After that I am calling my merge sort for my left part. After that I will calling my merge sort for my right part. So I will call merge sort for my right part. After that merge sort for my left part. So these function, this recursive call will get continued after after calling, like after dividing all the merge sort. First of all, what I am doing, I am dividing all those elements into single elements. After that I am calling my merge sort. When I call merge sort, the left part and the right part will get sorted. Now we need to combine those two elements, left part and the right part, in such a way that we'll get a final sorted array. So for that I am calling my merge function. So in the merge function, what I am doing, first of all I am creating a new array, new temporary array, which is equals to the size of the given arr dot length. After that here I am creating iterator int I is equals to starting index. So this will keep track of my left part. After that int j is equals to mid plus 1. So this will keep track on my left part, right part of the array. After that for our array, I am creating a new iterator int k is equals to 0. So I have created three iterators I, j, k. I is for my left part, j is for my right part, and k is for my temporary array. Okay, after that I am copying all the elements using a while loop. Right, I'm copying I'm arranging the left part and the right part elements by comparison. So in the while loop, what I'm doing, consider that I have written two if statement and the else statement, and after that I'm creating using those two iterators. I'm comparison. After that I'm moving those iterators. So if let us consider 3 and 5. So 3 is greater. So first of all, in my temporary array, 3 will come. After this iterator will move forward. After let us consider here 6, 5. So 5 is greater, 5 is less. So 5 will come here. After this iterator will move. After let us consider 6, 9. So here 6 is less than, right? So 6 will come in my temporary array and this iterator will move. These movement of iterators, I will copy all those elements in my temporary array. Suppose if any elements are left out in my left part, either in my left part or in my right part, for that left out elements I am running the loop, two loops for my left part and the right part, two whiles loop. After copying all the elements in my temporary array, I need to shift all those elements into my actual array, right? For that I am shifting all the elements of my temporary into my given array. After in the main program, I am printing those arrays. Now let me save this thing and run. So this is my given array, and you can see that I got my sorted array. Suppose if I am passing a negative element in this -1, and let me save and run again. So these code will work also for negative numbers, right? This is the code for merge sort. So in the previous basic coding algorithms, counting sort won't that much applicable for negative numbers, but this merge sort is applicable for any given elements without any particular range or without any restrictions. We can apply merge sort anywhere. So I hope you have understood the main logic and the code of this question. So let me dry run for you guys. The first step is we create our array in the main program. After that we have called our merge sort function. So the control will go from merge sort from main program to the merge sort. In the merge sort program, first of all I am calculating mid and I am dividing all the elements as my left part and my right part, and these division will continues until I get my base case. So if I got my base case, then I will do merge sort for my left part of the array. This is my left part and the right part. So I will arrange elements in the left part in a sorted fashion. After that I will arrange the elements which are there in my right part in the sorted order. Let us consider that 2, 3, 5, after 6, 9, 8, right? Okay, so first of all these are the sorted order fashion, right? So what merge sort right will do, merge sort right will sort the given left right part of the array like this 8, 9, right? This is the fashion of sorted fashion, right? 2, 3, 5, 6, 8, 9, right? These are the two things. After it, what I'm doing here, I'm calling my merge sort function. So in the merge sort function, you can see that first of all I'm creating a new array of my temporary size. So whatever the actual ARR size, that is equals to my temporary size. So the size of my temporary array is equals to our actual array length. So I have created arr dot length array. After that, here I'm like, let us consider that this is my first part. So this is my I. After that, this is my j, and k is here, right? Okay. So what I'm doing here, the size of my temporary is 1 2 3 4 4 5 6. So let us consider that these are the size of my array, because the elements I am taking is 6, right? So temporary array is 6. Okay. So here what I am doing in the while loop, what I am doing, this is my arr of I, arr of j. Okay. I am comparing if my arr of uh, I, that is 2, is less than j. Yeah, 2 is less than j. What I am doing, I am adding to my array. So 2 will get here. After that, I will increment first of all I value. So I will come here, right? I will increment I. After that, I will increment k. So iterator of k will come here. After that, here 3 and 6 will get compiled. So which is the smallest one here? 3 is the smallest one. So I will like put 3 here. After that, I will increment I. So I will increment I, and I will be here, right? And k will be here now. So among 5 and 6, which is the largest one? 6 is the largest, right? So I will like put 6 is the largest and 5 is the smaller. So I will put 5 here, and here there are no elements left in the while loop. So these condition will get like I should be less than or equals to mid and I plus plus. So I will go out of mid, and this condition will fail. This condition will fail, and there are like three spaces, and there are like three elements present in my right side of the array. So you can see that there are like some elements left out on my right side of the element array. So here I value is like greater than mid. So these condition will get fault, and this loop will not get executed, but this loop will get executed. So this loop will add 6 8 9 in my temporary array. So this will add in my temporary array 6 8 9. So this is how the temporary array will hold. And whatever, this is my temporary array, right? Temporary array is 2 3 5 6 8 9. So I will copy all the elements in my actual arr array. So I will copy all the elements of my temporary into my arr array. After that, I am printing it to my user. So this is the basic. So first one is call my merge sort function. In the merge sort function, return, first of all, write your base case, that is for single element. Si should be greater than or equals to ending index. If that particular condition is true, then return, right? After that, calculate mid value. After calculating mid value, call for left part, after right part, left part and right part, and sort the left part and right part by dividing and combining. After sorting, combine those two, left part and the right part, using merge sort function. After using merge sort function, copy the array, temporary array, into my actual arr element. After, print it to my user. So these all are the things going on. This might sound like a little bit difficult to you, but I hope you have understood the concept of the question. Like I took like around 1 hour to like teach you the only one sorting technique. I tried my best to explain you, right? So I hope you have understood. Now let us talk about another sorting technique, that is quick sort. Now let us talk about another sorting algorithm, that is quick sort. So there is an advantage of using quick sort, because the advantage is the average time complexity of like a quick sort is around the same as merge sort, that is big of log n. After it, in some scenarios, like when we like sometimes get in worst case scenarios, the time complexity might go into big of n square. We'll study that how time complexity, what is average case, what is worst case, and all those things in the next chapter, that is space and time complexity. So the advantage here of using quick sort is most of the times we'll get like average case only, because in some cases, in some like minimum cases, we'll get a worst case scenario, but most of the around 90% cases will get average case scenario. So for average case, time complexity is big of n log n. After the space complexity here, in the merge sort, what we used to do, we used to create a new array, right? So for creating n elements, we need n big of n space. But here we are not creating a new array. We are like adjusting, like some making new minor changes by Jugaad. We like making our array sorted. So we don't need a extra space. so the space complexity will become big of 1. This is the advantage when it comes to quick sort. Now what is the approach? How to do like a quick sort, or how to like apply a quick sort for a given particular array of unsorted elements? So the approach here, let us take an example that 6 3 9 8 2 5. So this is my given array, right? Let us consider that this is my given array, and the approach of quicksort is we use an approach called as a pivot and partition. So this is like very similar to divide and conquer, only like we are just giving the another name for approaching a quicksort. The approach name is pivot and partition. So in the pivot and partition approach, the first step we are going to proceed is, first of all, we will choose a pivot point. So in physics, you have already, I hope you have already studied about pivot points, like what are pivot points, or in simple words I can explain you that let us take this is my pen, right? So if any point of my pen is fixed and we are right moving around that particular point, you can see that I have fixed this point as my like pivot. This thing, the fixed point, is known as pivot, and my pen or all the elements are rotating towards or around the pivot. You can see that the pen is rotating like around the pivot. So this thing is known as pivot. So here we'll choose the element as my pivot, and we'll like rotate or like juggle the elements based on that particular scenario. Based on the comparison, we will like change the positions of my given elements in the array, right? Usually in most of the cases we can like take pivot of as first element or the mid element or the last element. In most of the scenarios we'll take our pivot as my last element only. So here I will take my pivot as 5. So this will become my pivot. So after taking pivot, what we need to do? We need to do, second step will be partition. Partition. So we like partition or divide the elements of my given array based on by comparison with pivot, right? So this is my pivot, right? So I will like arrange all the elements on my right side which are greater than my pivot element. After it I will arrange all the elements which are less than my pivot element. Here you can see that 6 is the greater element, so I will like arrange 6 here. After 3 is the less than pivot, so I will put 3 here. After 9 is my value greater than my pivot point, so I will put 9 on the right side. After it 8 is also greater, so I will put 8 here. After it I will put 2 here, and finally this is my pivot point, so I will leave it. So what is the approach? The second one is we do partition. What we do, we'll do partition. So we'll like arrange the elements in such a order that whatever the elements less than my pivot come on my left side. After it, whatever the elements which are present greater than my pivot point comes on the right side. So I will do left side, after it, left side and the right side. And for third step will be calling my quick sort for my left part and my right part. So you just have to believe that my quick sort will give me the like sorted elements for my left side and my right side. So this is the left side and this is the right side, right? So I will call quick sort for my left side. After that I will call quick sort for my right side, and these calling will continue until I hit my base case, and at the base case I will get my sorted array. So this will give me sorted array. So this is the approach, and I hope you have understood how we choose pivot. We usually choose a pivot point which is the last element present in our array. So whatever the array the user has given you, will take the last element as my pivot point. After that, the second step will be partition. So we'll like do partition according to my pivot point. So whatever the elements which are present on the left side of my array will are the elements which are less than my given like pivot point. If the elements are greater than my pivot point, then those elements will come on the right side. After that, after like doing partition, I will call quick sort for my third step will be calling my quick sort for my left part and calling my quick sort for my right part. So by calling quick sort, we will just you just have to believe that my recursion will give me quick sort of my left part and the right part. So after calling, what we get a final array as the array looks like this. That is 2 3 5. After that 6 8 9. So this will become my sorted array, and this is how we'll apply the quick sort for my given array. Right? Suppose I need to like explain a little bit more about partition step. So I hope you have understood how we choose pivot. After that, how we call like quick sort for my left part and my right part. So when we code quick sort for my left part and the right part, I will tell you the like how we going to use logic and what are the things that we need in the code. So when we write the code of quick sort, you will understand it even more better. Right? Now let us talk about how we can do partition. Here you can see that in the slide. Worst case occurs when the pivot element is always smaller or the largest. So if our pivot element which we have chosen is the largest or the smallest, then in that scenario we'll get like worst case. Remember guys that if we the point which we have chosen pivot, if it is the smallest element within the present array, or it is the given like largest element in our given array, then now and only we'll get our worst case. In all other scenarios we'll get average case. Okay, now let us talk about partition, how we like do division or divide the elements in between elements. Now let us talk about partition. So to do parts of my array, so this is the array, right? How many elements? 6 elements. So 1 2 3 2 3 4 5 6, yeah, 1 2 3 4 5 and sixth one. So these are my like elements of my array, right? So this is my array we have taken, that is 6 3 9 8 2 5, and these are my indexes 0 1 2 3 4 5. So I'm not like changing the elements whatever the I'm not creating a new array and anything like that. I'm like changing the elements within the array only. I'm not creating a new array. This is the only advantage we have for quick sort. Okay, so these are the elements which are present in my quick sort, right? In my array 6 3 9 8 2 5. Okay, so I will take a iterator I is equals to -1. So I will lie here, that is -1, right? Somewhere here I will lie. So here I will increment the value of I if the pivot value is greater than the element present at that particular location. What it means, I will tell you that here initially I is equals to 0, right? After that I will check with 6 and whether 6 is greater than 5 or not. Yeah, 6 is greater than 5, then don't do nothing. Do nothing. After that it will come here, right? Whether 3 is greater than 5, yeah, this condition is false. If this condition is false, what I need to do, I need to increment I plus plus. After that I need to swap the I value after the next element present at the I. So here from I is equals to 0, I will become 0, right? From I is equals to -1, I will become 0, and I will swap the elements, right? I will like 3 and 6. So I will swap these two elements. After that 5 will compare with 9. Yeah, 9 is greater than 5, then do nothing. After that 8 is greater than 5, yeah, do nothing. After that 5 is greater than 2, no, 2 is not greater than like 5. So what I need to do, I need to swap. So first of all I will do plus plus. Initially I is equals to 0, I will do 1. After that I will change here 2, I will put here. After that here I will put 6. So you, after like changing all the elements, I will take my last element and I will put in the middle, right? So my array will like transform like this: 3 2 5 9 8 6. So this is how my array will become, right? Okay, this is how my array will become, and this is my pivot point. So this is my pivot point, and this is my left part, and this is my right part. So I will call quick sort for my left part and quick sort for my right part. And after calling quick sort for my right part and left part, I will finally get my array like this. That is 2 3 5 8, sorry, 6 8 9. So this is my sorted array in my increasing fashion. So this is how we'll like apply quick sort. So what is the first step? First step will be find your pivot point. Usually it is the last element present. Okay, second point is do partition. right? For partition, we'll create a iterator I is equals to 1, and we'll compare with our pivot. If the pivot element is greater than my current element, then swapping will take place, increment the value of I after swap. So this is how the things work in the partition step. After third step will be quick sort for left, quick sort for right. So these are the three steps which we are going to perform for quick sort. Now let us code this thing. So I'm going to create my quick sort function, quick sort. In this, first of all I'm creating a function for quick sort, public static void type function. After quick sort, in this I'm passing my array int arr, after it int starting index, after it int ending index. In this, if starting index is greater than or equals to ending index, that is my single element, if I get my single element in the quicksort function, then what I need to do, I need to return come out of my function. That's all. This is my base case. This is my base case. After base case, I need to define my work. So first of all, I need to choose my pivot, right? So for quick sort, I need to choose my pivot. So usually we will choose last element as my pivot. So I'm going to create int p pivot index is equals to partition. I'm going to call my partition function, because I'm going to arrange the pivot point or the pivot location according to the comparison, right? According to the comparison, if whatever the elements present on the left side of my pivot side are less than my pivot point, whatever the elements which are present on the right side is greater than my pivot point. So this is how I'm going to do partition. So first of all, I am going to arrange the location of my pivot point. So for that, I'm going to call my partition function. Partition, the partition. In this, I'm passing int arr after starting index, after it ending index. That's all. After that, I'm calling my this is my work basically. So this is my work. After that, I need to inner function call. So in the inner function call, what I'm doing, I'm calling my quicksort function, and I'm passing int arr after it, starting index and pivot point. So I need to sort my left part, right? So what is the left part? Pivot index -1, right? Okay. So pivot index -1. Okay. After that, I need to call my right part. So I need to start from pivot index, after that ending index. So these thing will give me left part. This thing will give me left part of my array, right? After it, here this thing will give me right part of my array, right? Okay. So after that, I need to create my partition function. So for that, I'm going to create my function public static int type function, because I'm going to return the index of my pivot point, right? So int type function partition. In this, I'm going to pass int arr, after it int starting point, after it int ending point. In this, first of all, I'm going to create my pivot. Pivot is equals to arr of my ending index, because I'm choosing the last element, right? Last element, right? After that, int I is equals to starting index -1, because I is equals to starting index is 0 -1. So I'm going to initialize with I is equals to -1. Okay. After that, this is used to make place for small elements. So whatever this is used to make for place for small elements, after that partition also. For doing like partition, I am using a iterator, that is I is equals to, I'm going to initialize it with 1. After that, I'm going to run a loop for int j is equals to 0, and j should be less than or equals to ending index, after j plus plus. In this, I'm checking if arr of j is less than or equals to pivot. If yes, Then I need to increment I value. After that, swap, right? Swapping. So int temp is equals to ARR of j. After ARR of j is equals to ARR of I. After that, ARR of I is equals to 10. That's all. After that, I need to again after running my loop, I need to increment the I value again, right? That's all. After that, what I need to do, I need to like temp is equals to pivot. After that, ARR of ending index is equals to ARR of I. So I'm changing the ending element also. After that, ARR of I is equals to 10. Finally, return I value. That's all. So let me save this and run. So it is showing some kind of error. Yeah, here I need to start from j is equals to not from 0. I need to start my value from j is equals to starting index, and j should be less than or equals less than a, not equals to. Now let me save and run. So you can see that we have sorted the given array. So this is the given array, and by calling quicksort we have sorted the given array, and I'm in the main function I'm calling, or I'm running the elements. I'm running a loop to print my elements. Okay, so here let me tell you again that first of all I have created the array. After that I have called my quicksort function. So in the quicksort function, this is my quicksort function. So in the quicksort function, what I'm doing, first of all I'm checking my base case. So here this is like very similar to my merge sort. I'm like partitioning my elements, and if the element is like a single, if in the given array if the element is single, right, that is only one element is present at that particular scenario, that will be my base case. So what I'm doing, I'm like running my quicksort for left part and the right part, right? Here I'm like dividing, and if I got a base or a case in which only single element is present, at that particular scenario I need to come out of my function. So here this is my base case. After that I'm like checking the pivot point index. I am going to check the pivot point index, and these pivot point index will tell me that in this particular index I need to put my pivot, because I need to do partition, right? So for partitioning I need to correctly choose my pivot index point also, right? Here our pivot is at the last 5, so we need to bring our pivot in such a way that all the elements which are like less than our pivot point should be at left, and whatever the elements like greater than my pivot point should be at right. So to do that I need to change the index of the pivot, right? For that particular reason I'm calling my partition function. In the partition function, what I'm doing, first of all I'm storing the pivot value. After that int I is equals to starting index minus 1. That is I told you now that for partitioning I is equals to, we will initialize it with minus 1. After that, in whatever the case, I'm running the loop and I'm checking if the present current element is less than my pivot. If yes, then swap and increase the value of I. So I'm increasing the value of I. After that I'm swapping. After that here I'm like swapping the pivot value with the current element, because I need to like alter the position also, right? So when I like swap the two elements, I need to alter the position of the array also, right? For that particular reason I'm like changing the ending value after the I value. So this is how the pivot will work. After that these pivot will like partition all the elements. After doing partitioning we'll get a array in such a way that all the elements less than pivot will come on the left side. After it, all the elements which are greater than pivot comes on the right side. So after the elements on the right side and the left side, what we do? We do a quick sort for the left part and the right part, and quick sort will return me itself the sorted part of my left side and my right side, and by combining all those things we'll get a sorted array. Right here you can see that we haven't created a new array, whereas in the merge sort element you can see that we have created a new array, but whereas in quicksort we haven't created like a new array. So such that it is like kind of a kind of advantage when it comes to quicksort. So I hope you have understood the logic and the code. Now you can code this particular question, you can note this particular code in your notes like for quicksort. So this is the code. I hope you have understood the logic and the functioning of quicksort. Now we are going to see our next question, that is search in sorted rotated array. So first of all, let us understand this question, that user will give us a sorted array, sorted and rotated array with distinct numbers. What is mean by distinct numbers? That the elements which are present in our array is not repeating. Suppose like user will not give us an array like this 1 1 2 3 2, because in this array the elements are repeating. So these kind of array we don't get. After that, here the elements are in sorted order and those elements are rotated. Right, after that, in ascending order, the elements are sorted in ascending order. After that, they are like rotated in with respect to a particular pivot. I will explain you right how rotation and all those things take place. After that, it is rotated at a particular pivot point. After that, we need to find the index of the given element. Right, for example, here user will give us a target and we need to return its index. Right, suppose here this is the given array, right? This is not actually the original array, this is the rotated array. Okay, I hope you haven't getting it, because what is meant by rotation, or what is meant by like rotating around a pivot point. So to understand that, let us take example that I am having like elements of array like 1 2 3 5 8. So this is a sorted array in descending order. Yeah, in ascending order. This is a sorted array in ascending order in increasing fashion array. So what is the meaning of rotation about a particular pivot? The meaning of rotation is like there are two kind of rotation. So when you are solving a rotated array question, there are two kind of rotation. It is first one is left rotation, that is the whatever the left elements present, those will go shift towards the right side. Or right rotation, right rotations means whatever the elements which is present right side of the pivot point will go forward towards the left side. So let us understand that here this is our array, right? 1 2 3 4 5 6 1 2 3 4 5 8. Okay, so let us take an example that this is our pivot point and I am doing right rotation. Right, I am doing applying right rotation or rotating like right towards left. So these elements will go towards the towards front of my array. So my array will become 5 8 1 2 3. So this is known as right rotation. What is meant by left rotation? So this is my original array, right? 1 2 3 5 8. Left rotations means whatever, this is my pivot point. So whatever the elements which is present on the left side, those elements will come at the come last. So my array will become 3 5 8 1 2. So this is known as left rotation and this is known as right rotation. Right, yeah, rotation, whatever, yeah. So user has given us a sorted array and it is rotated. Right, it means that rotated and sorted array. So the user has given us a first of all rotated and a sorted array. Right, it means that the original array might looks like this, right? 0 1 2 4 5 6 7. So we have rotated the given array about a particular pivot. Here the pivot is, what is the pivot? 4 is the pivot, 2 is the pivot. So we have rotated right rotation. We did right rotation for the rest of my array. So the elements will become 4 5 6 7 0 1 2. So this is my rotated sorted and rotated array. Sorted and rotated array. So this is the given sorted and rotated array and we need to find the index of the target. Here what is the target? Target is 0. So the indexes are 0 1 2 3 4 5 6. So the indexes are, let me like first of all right here, it is not like kind of visible. So this is my array, right? This is my sorted and rotated array. Now I need to find the target index. So the target is 0. So the index are 0 1 2 3 4 5 6. So the index of my target is 0. So I need to return 4 as my output to my user. So this is the basic concept of the question. Now you can say that we can apply linear search and we can iterate to each index and we will find if the target is equal to my present element. If not, then move into next iteration. Yeah, these linear search will work here. Linear search will work here, absolutely work here. But the time complexity of linear search is big of n. So here we are going to do in a different approach. Like these question, the question which we are going to do, the algorithm which we are going to use might look like similar to binary search. But here the only thing you have to understand when we are going to write algorithm, and we are going to when we are going to understand the question, when we are going to code the actual thing, you need to understand the cases. In this question we will form like different cases to solve this particular question, right? So if you understand those cases, then this question is sorted, boss. Right, I'm telling you that if you understand these kind of questions, this will like increase your thinking ability. After that, if you understand the conditions, there is only one catch in this question. If you able to understand the conditions, then this question is easy. Now let us see how we can approach this given question. I hope you have understood the concept. Now let us talk about the approach of this question. Now this is my given array, and these are my indexes: 0, 1, 2, 3, 4, 5, 6, and we need to return the, this is my target, and our output should be 4, because the index of our target is 4. So we will return 4 as my output. So in this we are not using linear search. We are going with a different approach. So the approach here is before I dive into the approach, there are some conditions you need to understand. After that, by understanding the condition, we can directly go into coding part. Okay. So the conditions are, first of all, to understand how conditions are formed. Let me draw the like a graph of the given array. So let me consider that this is my in the x-axis, these are my indexes, and these are my elements. Okay. Now I'm changing my ink. Let me change to white. Okay. So here this is my at the first index, at the 0th index, this is my 4th element. After this is my 5th element. After this is my 6th element. After this is my 7th element. After that 0th element, first element, second element. So can I write that can I plot the elements as, this is my line 1. I'm writing this very very badly, but I hope you have understood, right? Can I write my these particular line by joining all the points? Let me like rewrite this again. It is like not so good, so I'm erasing this thing. Yeah. Okay. Yeah, these are my points, right? Okay. After, these are my second line points. So I am joining all this. This is my line, second line. After, this is my third line, this is my first line. So this is my first line, and this is my second line. Now I need to find out one thing. That my target, whether it lies in line 1 or whether it lies in line 2. If I can like able to find out a way that whether my target lies on the first line or in the second line, I can like directly tell that okay, this is the index of my array. So first step will be finding in which line, on which line our target is lying, whether it is lying in the first line or in whether it is lying in the second line. Or and you can also observe one thing, that this particular point will coincide with this point, and this particular point will coincide with this thing. Okay. So can you observe that thing, that the pattern or the line is a continuous line, it is not breaking, it is only coming to the down because of the particular element. Or else this line, if this is a sorted array, right? So if this is not a rotated one, if this is not rotated, then our line or our element should look like this, some kind of this. If we rotate, if after rotating these particular array, our graph become like this. Because of only rotation, our graph has become like this. If there is no rotation, then our graph should look like this. Okay. Now let us talk about conditions. So I told you that if I can able to find whether my target lies on the first line or second line. So to calculate the target, what I told you, that our approach is like similar to binary search. So in binary search, what we used to do, we used to calculate the middle value, right? So mid index is equals to starting index plus ending index divided by 2. Here we like do the same approach, we like follow the same approach. Here we will see that we will calculate first of all mid. So we will calculate mid is equals to starting index plus ending index divided by 2. After it, we will compare our ARR of mid. First of all, we will see whether our ARR of mid lies on the first line or the second line, right? So let us talk about conditions. First case is in the case 1, if our ARR of mid lies on the first line, that is L1, if our ARR of mid lies on first line, then in this we'll have again two conditions, like this is kind of a nested yeah, if else statements, you can say, right? So in the first statement, if error of mid lies on the first line, then we'll have again one statement that will check again that this particular, let us consider that let me, I'm changing the ink here again such that you'll understand it even more better. That okay, let us consider that on my first line our mid is like stay like lying on the first line. Let us consider that this is my mid. Okay, so our mid is on the left side. Then what is the condition? If our mid is on the left side, if our mid is on the left side, then the condition will be starting index should be less than or equals to target, and target should be less than or equals to mid, right? So if our target is less than mid, that means that our target lies here somewhere here. If this is the mid and our target is less than mid, then our element should lie somewhere here. Okay, got it? After that, in the second case, what if our mid value is less than my target value? It means that my target will lie somewhere here. Okay, our case 2 will be, our case 2 will be on line 1 right side. That is, our mid is less than or equals to our target, and our target is less than or equals to ending index, right? So this is the condition I have obtained on if the particular target or our particular mid value lies on first line. So let us talk about second line. Case 2, if our ARR of mid lies on the second line, it means somewhere right here. Let us consider that somewhere right here, right? Okay, so in this we'll also have two cases. Let us consider case 3, that on line 2 our our element, our target lies on the right side, like somewhere right here our target is here and our mid is here. So on the right side our condition should be first of all our mid should be less than or equals to target, and target should be less than or equals to ending index, right? Okay, our case D should be if our on the line L2 our mid lies somewhere here, then our left condition should be false in the else statement, right? Mid left, so our else statement should come into else statement, and we will check with the respective elements on the line second left side. I hope you have understood the concept here. Now let us if you understood the concept, that case 1, in the case 1 we'll check whether our mid lies on the first line. If it is lying on the first line, then we'll check for like with the starting index, whether on the left side of my line 1 or whether on the right side of my line 1. Similarly goes thing with similarly we'll check for if our middle elements lies on the line 2, then we'll check whether the particular target is lying on, let us consider that this is our mid on the line 2. We'll check whether our target is greater than our like mid values. It is, then it will lie on the right side. If it is not, then it will lie on the left side. So this is a basic concept, and this is like kind of similar to binary search, right? So in binary search what we used to do, we'll like first of all calculate mid, after it we'll check our key. If it is like lying on the right side, then we'll change the value of start, and if it is lying on the left side, then we'll change the value of end. Similarly this thing goes on here, and we'll using the concepts of binary search to approach this particular question. Now let us code this thing. Let me create my function search rotated array. So in this I'm creating my function public static int type function, because I'm going to return the integer of the given index. Okay, after that I'm calling my search function. Search, in this I'm passing int ARR comma int starting index comma int ending index. In this, what is my base case? Base case should be if my starting index is greater than ending index, then simply return -1, that is my element is not present in the given array, right? Okay, after it is showing some kind of error, that is method must be written. Okay, we'll return no worries. Okay, after that we need to do our work. So what is our work? Int mid is equals to starting index plus ending index divided by 2. After that, if our let us consider that we got like a target right away, that our target is the mid value. That is, if our mid is equals to target, here we need to pass target also, right? Okay, I'm passing int target. Okay, so if our target is equals to mid, then we need to return the mid, that is the index, right? So we need to return mid. After that, here we need to check for mid on line 1, mid on line 1. So what is the condition for mid on line 1? If our ARR of starting index is less than or equals to mid, then we need to first of all check case A, that is left side of my line 1. So here in this ARR of starting index is less than or equals to target, and target is less than or equals to ARR of mid. If this is the condition, then we need to write change the end value, right? So in this we are calling our function recursively, and I am changing the value, the ending value by mid minus 1. Okay, here in the previous binary search we used to do with iterative approach, and here we are doing with recursive approach. Okay, after that, here in the else statement, it means that if on the right side of L2, right? Okay, so here we need to change the value of starting index. So what we need to do, we need to do mid plus 1, that's all, right? After it, if our element lies on the second line, that is, this is the second line, ARR of mid lies in the second line, we need to check again. This is our case C. So if our ARR of mid is less than or equals to target, and is less than or equals to ARR of ending index, it means that it lies on the right side. So return search. In this we need to change the starting value by mid plus 1. In the else statement, return search, and we need to change the ending value here, right? Mid minus 1, that's all. Here we need to do statement terminator. So this case is for right side. Here this case is for left side of my line 2. Okay, and this case is for right side of my line 2. Okay, now let me save this, and here I need to give ARR of mid. Okay, now let me save, and here in the place of calling quicksort, I'm calling my, I'm first of all printing whatever the value returned by my search function. Here I'm passing search ARR starting index, ending index is ARR dot length minus 1. After that I need to pass a target, let us pass 9. So if I pass 9, then I should get output as 0, 1, 2, 2 as my output. Now let me save and run. So you can see that I got my output as 2. So 2 is the index of the array. Now, right, this is how we used to search, right? This is the code for searching element in our sorted array. So I hope you have got the logic. If you want to write down the code, then you can write this, pausing the video, right? This is how the working of my code works. First of all, we will check the base case. If the element is not present, then return -1. After that, we need to calculate mid value. If the mid value is equals to target, then immediately return the mid index, that is the index of the present element. If not, then check for line 1. If it is lies on the line 1, if it is if the particular target lies on the line 1, then we need to check whether it is greater than mid or less than mid. If it is less than mid, then it will come here. If it is greater than mid, then it will come here, right? Similarly, if the particular target lies on the second line, then it will come in the else block, and these statements will get executed, and finally will return the index of that particular in particular target. So this is how the code works.